right, so we are going to look at a little bit more of these parallel lines and angles again. This is really just a continuation of yesterday's lesson, and it's going to be a bit of a review of yesterday's lesson, but I have found that kids kind of have a hard time really solidifying with the vocabulary and everything, so we're just going to take another day. And we're also going to look at something that's really, really important. Now, look at L1 and L2, right? We've got, where'd my mouse go? Where did my mouse go? There's my mouse. We're going to change it to a pencil so you can see it a little more easily. L1 and L2. Are they parallel? How do you know? How do you know if they're parallel? They sure look like they're parallel, right? You're looking at that going, sure looks parallel to me. Have you measured? Have you measured all the way out to infinity that those are parallel? Because remember, lines go on all the way to infinity. What if they're just the tiniest little 100th of a degree off and they totally look parallel to our eyes because we're people, but they're not, and they're going to cross clear over there in Texas where they're going to cross. Do we know that they're parallel? Guess what? They're not. They're not parallel. And how do I know that they're not parallel? Because I don't know that they are. And if I don't know that they are parallel, then I cannot assume that they are. So this is our biggest rule. Unless I tell you that they're parallel, they're not parallel. So here's what I'm going to do. L1 is parallel to L2. But I'm a mathematician, and there are other mathematicians. And guess what, guys? Mathematicians are a little bit lazy. So we have a little shorthand that I'm going to teach you. L1, and then there's two vertical lines, L2. Those two vertical lines mean that they are parallel. L1 is parallel to L2. L1 is parallel to L2. We're just being lazy and writing some shorthand. It's kind of like an equal sign, means these two expressions on either side here are equivalent to each other, right? Like I could say x plus 3 equals x minus 2, right? The equal sign means, hey, the two things on either side have the same value, right? This sign right here means, hey, these two things are parallel. So when you see this, it means that they are parallel to each other. So now we know that L1 is parallel to L2, so now we can have all the fun, and now we know about all the angles. None of these angles have guaranteed congruence if they're not parallel, but now that we know that they're parallel, then we know that this set of angles was translated down with a rigid transformation into this set of angles, and we can do all the things with it. So let's review some of our vocabulary that we learned yesterday, okay? Let's review corresponding angles. Corresponding angles give people problems because corresponding and congruent both start with the letter C. And so you've got to get past the letter C. If line 1 and line 2 are parallel, then the corresponding angles are going to be congruent. But if line 1 is not parallel to line 2, of course, they're not congruent. But corresponding angles are congruent, but congruent angles aren't necessarily corresponding. Okay, and angles are never, ever, ever parallel to each other. Only lines can be parallel. If you tell me that the angles are congruent because they are parallel, I will shake my head and want to cry. So, and it happens every year. Please don't be that kid. So let's look at the corresponding angles. So we have angle 1. If we translated angle 1 down along this vector, it would be angle 5. Boom. So angle 1 and angle 5 are corresponding angles, and they are congruent. Okay, let's look at angle 2. If we translate angle 2 down, it is angle 6. Are they congruent? Heck yeah, they're congruent because they're corresponding angles. Oops, I wanted to write 2 first. So we have angle 2 and angle 6. I could write 6 first. It means the same thing, but I wanted to write 2 first. What about angle 3? Angle 3, translate that down, and then it's angle 7. Angle 3 and angle 7 are corresponding angles, and angle 3 and angle 7 are congruent, okay? Angle 4, translate that down. It's a rigid transformation, so they're congruent, and they are corresponding. So 4 and 8 are corresponding, okay? So what about vertical angles? These ones, remember, if we had a line down the middle and we reflect 1 over the line, it becomes 4. So 1 and 4 are vertical angles. So let's list the vertical angles. Okay. So vertical angles, I already said 1 and 4 are vertical angles. And then we have 2. Which angle is a vertical angle with 2? Well, if we look across, is there, wherever you have 2 cross lines, it doesn't matter. The 2 across from each other are going to be vertical angles. Here we have line 1, and then we have M, and M is the transversal, and those are the 2 that are crossing. But it's true with any random angles. In fact, let's write up over here. M is the transversal. That's an important piece of vocabulary too. M is the transversal. All right, so we're still going on vertical angles. We just scrolled for a second. So we have 1 and 4. Now we have 2. Which angle is a vertical angle with 2? We have 2 and 3. I think I already did that one. I just didn't write it down. 2 and 3. Then we have 5 and 8, because 8 is across from 5. And then we have 6 and 7. Our vertical angles. Are vertical angles congruent? Vertical angles are always congruent. You don't have to have a parallel line involved. These 2 are congruent. There's no parallel lines in this thing at all. But these 2 angles are congruent. So vertical angles are always congruent with each other. And we don't care if there are parallel lines involved. Vertical angles are always congruent. And they show up in other places. You can't have corresponding angles. You can't have alternate interior, and those aren't going to be congruent unless you have parallel lines. But the vertical angles are always congruent. All right, so the next kind we have over here, alternate exterior. Now remember, if line 1 and line 2 are an Oreo, right, the cookie part of an Oreo, the outside of the Oreo is the exterior. You use exterior paint on the outside of your house, and the angles on the outside of this line or these 2 lines are the exterior angles, okay? So the alternate means they are on opposite sides of the transversal. Remember, M is the transversal. They're on opposite sides. So if you look at angle 1, like if we looked on the same side as the transversal, clearly angle 7 is not congruent with angle 1. Like, we're not even pretending to be congruent here. But angle 8 is the alternate exterior. It's on the opposite side of the transversal. So 1 and angle 8 are alternate exterior angles. Are they congruent? Yes. Yes, they are totally congruent. Angle 2 is on the outside. Which one's its alternate exterior angle, buddy? Down here on angle 7. Angle 2 and angle 7 are alternate exterior angles. Are they congruent? Oh, yes. Very, very much so. All right, one last set of angles. We have alternate exterior. Which one do you think we need? We need alternate. What's the opposite of exterior? Interior. You can only buy 2 kinds of paint. You can buy, well, I mean, you can buy craft paint, right? But if you're going to paint your house, you're going to go to a paint store, you can buy exterior paint and you can buy interior paint. Now we're going to look at the interior, which is the inside. If you're going to use interior paint, it's on the inside of your house. Exterior paint is on the exterior of your house, the outside. Interior is on the inside of this Oreo where all the white fluffy goodness is, right? So let's look at the angles on the inside. We have 3. That's one of the angles on the inside. What's its alternate interior angle, buddy? We're going to look at the other side of the transversal, and 6. 6 is its alternate interior angle, buddy. Boom. Number 4 is another one. It's an interior angle. And where's its alternate, buddy? On the other side of the transversal? 5. All right. So let's play with this for a minute here. What if 1 is 55 degrees? Can I predict what angle measurement 5 has? Well, I can look at this and go, okay, I know that L1 and L2 are parallel because Mrs. Barlow told me. And so 1 and 5 are corresponding angles. So if 1 is 55 degrees, that means that 5 is 55 degrees. And if I look at an angle 2, let's change these angles up a little bit. If I look at angle 2, and I say, okay, angle 2 is 135 degrees, can I predict what angle 7 is going to be? Let's look at angle 7. So angle 2 and angle 7, I know that L1 is parallel to L2 because I said so. Angle 2 and angle 7 are alternate exterior angles. Oops, I didn't finish this one with 4 and 7. No, 4 and 5. Whoops. One of you would have gotten a piece of candy if you pointed that out to me. Okay, so we have 4 and 4. 2 is 135 and 7. Well, 7 is alternate exterior buddy, so 7 is 135. See how that works? So I want to take a peek at your assignment because there's some important things I want to call your attention to on your assignment, okay? I want you to look at how much your assignment is asking you to do. It says identify all pairs of corresponding angles. So that's one thing that you need to do. Are the pairs of corresponding angles equal in measure? Answer the question. How do you know if they're equal in measure? Tell me, okay? Identify all the pairs of alternate interior angles. You've got this little thing down here. Are the pairs of alternate interior angles equal in measure? I don't know. You tell me. How do you know? You got to tell me that. Use an informal argument to describe why 1 and 8 are equal in measure if L1 is equal to L2. So let me tell you what that means. Just tell me why. If we were here in class, if I was here today, which I'm not, but if we were here in class and you needed to tell me why angle 1 and angle 8 are equal in measure if these two are parallel, well, why are they? What kind of angles are they? Look at this. They're alternate exterior angles. So are they equal in measure? Yes. Why? Because they're alternate exterior angles, and alternate exterior angles are equal in measurement. Okay. And then you answer these. But I just want you to be aware how many parts are on these. Assuming L2 is parallel to L1, if the measure of angle 4 is 73, what's the measure of angle 8? And how do you know? So this one has 2 parts, guys. You get points for every single one of these parts. And if you skip a part, you lose points and you lose the bonus for having your assignment be complete. So please be aware of that and watch out for it. Good luck on your assignment. I think you will do fine. And let me know if you have any questions.